Hello, good evening everybody. My name is Vishwadeep and I welcome you all on Unacademy Computer Science channel for unlimited learning. In this session, we are going to talk about searching in the array, which is linear search and binary search. So what are these searches? How these are applied, what are the complexities, and why these are important for us to discuss about today. Everything we will discuss in this particular session. All those members who don't know about me, let me introduce myself first before we start the session. My name is Vishwadeep and I'm working as a channel leader on this particular channel and the leader of Unacademy Computer Science team under the content sales division of Unacademy. I have written the GATE exam multiple times. Apart from 1919, 440, 682 are few of the ranks. I went for my masters to IISc and another masters, BITS Pilani, rich experience in teaching. These are the courses I am going to cover this time on the Unacademy's platform for you guys. If you are aware of Unacademy's platform, well and good. If not, then Unacademy is India's largest platform today for learning online. So go to unacademy.com or download Unacademy Learner app, search my name and follow my profile. Once you follow my profile, under my profile you will be getting so many special classes. Yes, my dear friends, so many special classes you will be having. Those special classes you can listen in the live mode. Apart from that, you can listen all my previously taken special classes which are having topics, which are having practice, revisions, marathons and multiple other things, quizzes and one-liner questions for your theory practice and multiple other things. If you are the first time user, use this particular code VDEEP10 so that you can just unlock the free classes. This particular class is already going on. If you want to learn operating system, there is another class at 9 a.m. tomorrow. Use this code VDEEP10, unlock this particular class and learn live tomorrow. Upcoming special free class on Unacademy's platform. If you are waiting, sir, we will be going with self-preparation, notes, content, YouTube, everywhere the content is present, but you won't get immediately practice question after the classroom. You will not get the doubt solving, you will not get weekly test to assess your preparation, you will not get that this particular strategy is fine or not, you will not get the guidance over there. And all these are the prime factor apart from the content to get the rank, and that we provide on Unacademy Plus for you guys. So if you are still waiting, don't wait, take your decision as soon as possible and take the subscription of Unacademy Plus as soon as possible so that you can have your more structured, organized, efficient and effective preparation started as soon as possible. This Unacademy Plus subscription is available for 1 month, 3 months, 6 months, 12, 18, 24 months. If you are preparing for GATE 23, definitely you should go for 24 months so that you will be paying minimum amount per month, but you will be getting maximum out of that subscription. If you use the code VDEEP10, you will be able to get 10% discount, but the discount will not be only for this particular code. If you use the code, this is not only the discount code. This particular code will give you my mentorship, plus this particular code will make your preparation connected with my team. There is a team of some educators. That particular team will help you, will give you guidance, will be connected with your preparation every time. Apart from that, we have one more subscription, which is iconic subscription. In this iconic subscription, you will get all the facility of Unacademy Plus extra facility of having a personal coach. The personal coach will give you preparation strategies, study planner, booster sessions, personalized test analysis and study materials and extra so much of things. So this is that subscription which can make your college iconic, which can make your GATE rank iconic. So if you want these to be iconic, you go for Unacademy subscription iconic. Iconic subscription is available for 12 months and 24 months package. And if you want to go for this, you can use this code again so that you can get discount, plus you can get some other benefits of my mentorship, of connecting your preparation with my team. Look at this. This is the team of top educators, and there are certain more number of educators who are going to teach you on Unacademy plus in multiple बैचेस. चलिए तो स्टार्ट करेंगे सेशन को, और जल्दी से आप सब लोगों को मैसेज करना है अभी, आर यू गाइज रेडी और नॉट. इफ यू गाइज आर रेडी देन वी विल स्टार्ट द सेशन. जैसे ही आप लोग बोल देंगे यस यू आर रेडी, टाइप डाउन इन द कमेंट बॉक्स रेडी रेडी रेडी, एंड आई विल बी गोइंग विद द सेशन टुडे व्हिच इज सर्चिंग इन द एरे. Okay, so ready or not? Immediately tell me रे बाबा, बोलने का है. These sessions are interactive. Why? Just because I am trying to talk to you and I am asking the questions again and again. So if you will be responding, definitely these sessions will be more effective for you to remember. Learning is very easy, guys. I will make your learning very easy. I will explain everything very easily, but the biggest problem is how you will remember these things, and for that you will have to be very very interactive. Check. Arnab, can anyone choose multiple guide on Iconic? Arnab, no. You will be having one expert assigned from the Unacademy side, and apart from that expert who will be working very closely on your specific performance and on your daily to daily strategies and other things, you can do one more thing. You can get subscription using somebody's code. Like if you can use my code, then you will be getting my mentorship also along with that. So you will be having two mentors. I will be mentoring you day to day, maybe some time to time, timely basis, and you will be having one personal coach. That fellow, that expert will be working on your performance always. So you will be having a double benefit out of it. चलिए, ओहो क्या आ गया? Oh, yes. So searching in the array. There are two types of searching we have in the array. One is linear search, one is binary search. But I guess if you all know, well and good. If you don't know, then let me tell you. But I feel कि maximum लोगों को ये चीज पता होगी. That is this, that if you have to apply binary search, then binary search is having a very specific prerequisite, a pre-requirement. Requirement is what? A prerequisite is what? किसी को पता है? Prerequisite is the array should be sorted. Array should be sorted. I guess आपको sorted का मतलब तो पता होना चाहिए, है ना? Means array should be either in the ascending order or descending order. Then only you can apply binary search. Otherwise, if array is not sorted, then you should go with the linear search. चलिए आगे बढ़ते हैं, एक एक करके देखेंगे. One by one we will see. Linear search. First of all, let's say linear search. Linear search is very very simple. Very very simple. Linear search is nothing but searching your socks in house one by one place. Once you will check your socks on your bed, after that your chair, after that your table, after that your shoes, after that your cupboard, and then somehow you will find it, or else you will call mom, mummy मेरे socks कहाँ रखे हैं, right? But linear search is very simple. If you are searching any element, you just compare if that element is present on the array at very first index or not. If present, well and good, I am happy, I am lucky, I got my element, done, my searching stopped. But if the element which I am searching is not present here, then what should I do? What should I do? I'll have to go to the next. I'll compare this element, that at this position element is present which I am searching. No, then this, no, then go to the next. If not this, then keep going till the last. If I get that element, I will stop my searching. If I don't get element, then what? then what? Then I will return that element is not present. Some kind of index I will be returning. Right. So let's say this is the index lower bound and this is the index upper bound. Fine. Now, if I want to write down the algorithm of linear search, what I will do? I will have one index k, or let's say write a loop. I am writing a loop. So for loop I am starting k is equal to lower bound, k less than equal to upper bound, k plus plus. So loop I have written, I will start the index from lower bound, I will run the loop till index reaches to upper bound, then every time plus plus. Now what should I write inside this particular loop body? I should write the comparison. If element at array on index k is equal to the item which I am searching. If it is equal, then I will return k. Why? Just because I wanted to find out. I wanted to find out that element is present in the array or not, and if it is present, return me its location, where exactly it is available. So I will return its index, that on this index in the array the element is present. I will return it. If not, then it's okay. Keep going. Keep going. Loop will keep going. Fine. So I will close the loop here. Once the loop is done, and suppose for every element this particular condition was not true. Every element, if the condition was not true, अब क्या करेंगे? If the condition was not true, अब क्या करेंगे? अब हम return करेंगे. So what happens? K is equal to lower bound, condition not true, we don't return anything. Then K equals to lower bound plus 1. Here condition not true, not true, not true, not. Then K becomes upper bound plus 1, less than condition false. We will come out of the loop. When we come out of the loop and still this condition was not true, we will not return K. Then what we will do after the loop, we will return lower bound minus 1. Why we are returning lower bound minus 1? Why not only minus 1? Just because it is data structure, Babu. And you all know what? This particular lower bound can be 0, can be 1, can be 2, can be minus 3. Understood? Understood? समझा कि नहीं रे बाबा? समझा कि नहीं? समझा ना? Right? Now, tell me, if element is present here only, suppose I am searching 1 and it is present on lower bound only, what happens in that case? In that particular case, this loop runs only one time, first time condition true, and we will return. But if element is not present at first place, then we can get it here, we can get it here, we can get it here, we can get it here. Means this particular loop can run for how much time? This particular loop can run for how much time? कितनी देर के लिए लूप चल सकता है? ये चल सकता है maximum n times. This particular loop will run maximum n times. If this loop runs maximum n times, is there any possibility that this loop can stop even before n? Yes. In one time only? Yes. In that particular case, the time complexity, runtime complexity of this particular algorithm will be big O of n, not theta of n. Why? Just because theta of n means always we will have to run the loop n times, but here no, not always. Only sometimes it will go maximum up to n, sometimes it can stop even before that also. Maximum n steps, that is why complexity is big O of n. Got it? Sure. Fine. Okay. Time complexity is this. If somebody asks that what is the best case complexity? Best case complexity you can go for constant. Why? If the element is present at the very first location only in the constant time. So lower bound is constant time, but appropriate complexity is big O of n time. Fine. Understood? Now See, if element is present here, suppose I am searching 1, what I will return is lower bound, right? Suppose lower bound is starting from 3, so what I will return 3. If element 7 I am searching, I will return 4. If element 12 I am searching, I will return 5. Means when the element is present, what exactly I am going to return is where it is present. But when the element is not present, I'll have to check out, I will have to return such kind of index which is not the part of my array. So what I will return, one less than lower bound, this index which is not the part of my array. Hence the receiver of this value can understand key element is not present, that is why this particular index has been returned. So if I will write, this return will come or will work for successful search. What does it mean by successful search? That element is present and unsuccessful search. अब आप बताओ कि अगर आप अपने घर में अपने सॉक्स ढूंढते हो तो कितनी बार आपका सक्सेसफुल सर्च होता है और कितनी बार अनसक्सेसफुल, आपकी तरफ से, नॉट मॉम्स की तरफ से. कितनी बार आपको अपना ब्लैक टी शर्ट अपने खुद से मिल जाता है सामने का सामने रखा हुआ, या फिर मम्मी को आने की जरूरत नहीं है ना. मम्मी आती और फिर बोलती अरे यही तो रखा है, ये क्या रहा, तेरे को दिखा नहीं, आंखें हैं कि बटन है, बोलती मम्मा ऐसा. चलो आगे बढ़ते हैं. लीनियर सर्च का एल्गो ऑलरेडी आई हैव रिटन ओवर देयर. सो नेक्स्ट इज बाइनरी सर्च. ठीक है. नाउ बाइनरी सर्च का, एज आई ऑलरेडी टोल्ड यू, द requirement, prerequisite is what? Prerequisite is the array should be sorted. राज, मॉम्स लीनियर सर्च नहीं करती हैं. मॉम्स को पता है कि उन्होंने सामान कहाँ रखा है तो उन्हें मिल जाता है, राइट. एंड दैट इज कॉल्ड एज हैशिंग टेक्निक. इंसर्शन के टाइम पे आप एप्रोप्रिएट जगह पे रखो तो सर्चिंग आसान हो जाएगी, वहीं पे सर्च करोगे मिल जाएगा. दैट इज हैशिंग टेक्निक. चलिए जब आएगा तब पढ़ेंगे. अभी बात करते हैं बाइनरी सर्च के बारे में. बाइनरी सर्च काम कैसे करता है? बाइनरी सर्च वर्क्स ऑन द बेसिस ऑफ हाउ यू ओपन अ पेज फ्रॉम अ बुक. इफ आई एम आस्किंग यू ओपन द पेज नंबर 175, so some middle page you will open randomly, or one by one you will go to 175. No, if the book is of course arranged in the sequence number, then 175 will come after 174 number of pages. So of course you will not go one by one, you will open some random page. If suppose after opening random page you have reached to page number 210, so if you have reached to page number 210, you will go towards left side. Why? Just because you know the sequence numbers are the sorted ones. If the sequence number are sorted ones, then always it happens that you will have to go towards back side previous pages so that you can get page number 175. Of course बड़ा तो होगा नहीं 175 210 से, right? So you will take some more pages towards left side. And suppose you have reached to page number 160. Now from 160, 175 is greater, you will go towards right side so that you can get to the page 175. You will keep doing this and you will reach to page number 175. Exactly same thing. Exactly same thing you need to do. For what? Exactly same thing you need to do. For what? Binary search. What exactly you do in binary search? If you have an array, you find out some mid index here. This is the middle. This is the middle. If you are searching an element, then with middle element you compare. If at middle place you got the element, well and good. If not, then you need to check out the element which you want to search is less than 15 or greater than 15. If it is less than 15, then it can be only in the left half of the array. Why? Just because array is sorted. That is why. And if it is greater than 15, then it should be in the right side or right half of the array. So after one comparison, my problem will be reduced up to only n by 2 elements. Up to n by 2 elements. Why? Just because after one comparison, either I will search my element either in the left side or in the right side. Right? And then again, if you are suppose going towards right side, again you will find out middle and you check that at the middle you got the element. No, then either you will go towards left half or right half. So after every comparison, your list will become half, 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 half. And of course, in that particular case, you will be having your time complexity very less. Why? Just because after one comparison only you have dropped either these n by 2 elements or these n by 2 elements. So एक comparison के बाद after one comparison n by 2 elements got eliminated anyway. You don't have to compare those, you don't have to consider those for your comparison. Of course the complexity will be very less. Here it was not the case. After one comparison, you were not dropping more than one element. You have dropped only this element, but still n minus 1 elements were left. Then compare this. After that, only this comparison and only this element got dropped. Remaining all elements will be there only. After dropping this, only one element got dropped. No any other element eliminated. And because of that, complexity is very high, linear. एक काम करते हैं, बाइनरी सर्च का समझ में आया आपको? यू अंडरस्टूड व्हाट इज द बेसिक ऑफ बाइनरी सर्च. नाउ लेट मी एक्सप्लेन. Let me explain. First case, search 15. So first of all, what should we do? Let's take some indexes of these elements. Okay, so let me take index starting from 0. Very easy case of C language only. Fine. Now look at this. How to find middle index? You need to find middle index by the lower bound low plus upper bound high divided by 2. So right now lower bound is 0. So you find mid by lower bound 0 plus upper bound 9 divided by 2. It's integer value. It's integer means floor value. You can take 4.5 means floor value is 4. So middle index is 4. What you need to do is check on index 4 if element 15 is present. 15 is present? Yes. One comparison done? Yes, done. So what I will do is I will compare if at middle index in my array A, the item which I am searching, item means the element which I am searching, this 15 is present or not. Yes, present. Fine, means yes, return mid. We will get done. My algorithm will stop here. Yes, I got the element at this index 4. I will return that index. Good. Now this one. Let's see another example. Why I am explaining another example or multiple examples, so that you guys can understand how this binary search works. Okay. Now listen. Search 23. If I am searching 23, first of all you find mid. How do you find mid? So suppose this is the lower bound. Hai? This is the lower bound low value and this is the upper bound high value. Right? Index is same. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Fine. Let's first of all find mid. Mid is equal to 0 index plus index 9 divided by 2 is equal to 4. At index 4 you have searched the element 15 present? No. So I am checking if A of 4 is equal to 23. No. Right? If no, then we need to check out कि this element which I am searching 23 is greater than 15 or lesser than 15. is greater than 15 or lesser than 15. If it is greater than 15, then I will search towards only right half. If it is lesser than 15, then I will search only in the left half. So what I am searching is this: if the element which I am searching, item, is greater than a of mid, then what I'll do, I'll go towards only right half. How do I search, or how do I reduce my search towards right half? What I will do is I will update my low towards right half. That's it. So what I will do? What I will do in this case, I will update low by mid plus 1. So that anyway this element got eliminated. Yes, at index 4 element is not present. These also eliminated. Why? Just because these all are lesser than 15 and my item is greater than 15. So what I am doing is this L is equal to mid plus 1, or else if item will be lesser than a of mid, if that will be the case, then in that case what I will do, I will go towards left side. Agar item 15 se chota hota, the item which I am searching which is lesser than 15, I'll go towards left side. How do I go towards left side? I will update my high by mid minus 1. What I will do, I will update my high by mid minus 1, so that in the next time I will have the comparison either in the left half or in the right half. That's it. So if this is no, I will check this condition is true or this condition is true. Item 23 greater than 15, yes. So what I will do, I will update my L sorry, L by mid plus 1. Done. Okay, fine. So L is now 5, H is at 9. Now what I will do, I will update my mid again. Update my mid again. Update mid by what now? L at index 5 plus H at index 9 divided by 2. How much? 9 plus 5, 14 divided by 2, 7. Element at 7. This is the mid now. 29. 23 equal? Not equal. What should I do in this case? What should I do in this case? I will have to check this. If item is greater than a mid or not. If item is greater than a mid, 23 greater than mid index 29, no. Mid index element 29. Item is 23 greater than 29, no. If not, then what should I do? Oops. Here I made a mistake. It is mid minus 1 here. Yep. Fine. Okay. So what should I do here? What should I do if 23 is not greater than 29? What I will do? I will go item 23 is lesser than 29, mid index element. Yes. Then high I will update by mid minus 1 here. Now low is 5, H is 6. Again you calculate mid. Now again you calculate mid. 5 plus 6 divided by 2 is equal to how much? 11 by 2, 5.5. It is 5. So mid is 5. No problem. Don't worry about that. Don't worry. हमारा algorithm कहीं ना कहीं तो रुकेगा. Don't worry about that. Fine. Mid is 5. Okay. Now element at index 5 is equal to the element which I want to search. No. 23 is not equal to 21. Fine. False. Fine. Now I am checking item which I am gonna search. 23 greater than mid index element. Yes. Greater. Now what should I do? I'll have to update low by mid plus 1. Low and high will come here. Low and high will come here. Again I will search. I will find out mid index. So low is 6. Mid or high is 6. Divided by 2. 6 plus 6 divided by 2 is 6. Mid also at 6 only. Mid also at now 6 only. A of mid. इसको और थोड़ा क्लियर कर देते हैं. If item is equal to a of mid अगर है, yes got the element, yes return कर दो mid. गॉट इट? समझ में आया क्या? समझ में आया क्या? Right. So we are just having some examples. Let me take another example. One more example we are having so that you can understand how this particular algorithm goes. Suppose if I am searching an element. Suppose if I am searching an element which is not present in the array, how will I stop my algorithm? ये तो चलते जाएगा. This will keep going. If I will not stop my searching, this will keep going, right? So how to stop my searching? For that we will have to write one particular condition, and the condition is if I am searching, and if when the low value becomes greater than h, when the low index value becomes greater than h, when low and high will cross each other, at that time I can understand that element is not present. You have crossed your final limit. Element is not present. It is unsuccessful search. You need to stop your algorithm here. So unsuccessful search, the condition is when low crosses high. Low initially starts from here, high initially starts from here. Either low will be updated or high will be updated. These will be updated half list we will do every time once low and high will cross each other. At that time what you will have to realize is element present nahi hai, element is not present. You will need to stop here. Oops. Internet is working but there is no any power. Wait for few minutes. Please don't go away. I am here only. I guess my voice will be audible to you guys. Power went. Oops, it came back. Don't worry, it came back. Okay, so let's search an element which is not present in the array 10. Index is same 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Fine, now look, listen this. One minute. Okay, so we are trying to search an element which is not present. In that case we will have to stop on this particular condition. Okay, so first of all low is at 0, high is at 9 index. Fine, first of all we will have to find out mid. Mid is what? Mid is 0 plus 9 divided by 2, which is 4. Fine, low is initially 0, high is initially 9. You have calculated 4. Fine. Now we need to search at index 4 element 15 equal to 10. No. Now we need to check 10 is greater than 15 or lesser than 15. 10 is lesser than 15. If 10 is lesser than 15, we should go towards left side. If we should go towards left side, we need to update h. We need to update h by what? We need to update h by mid minus 1, this one. So h is equal to mid minus 1, index number 3, this one. Index number 3, this one. Fine, now listen. Again we need to find out mid. New mid will be what? 0 plus 3 divided by 2, 1.5, which is 1. Mid is 1 here. Now at one index, do we have element 10? No, we don't have. If we don't have, what should we do? We need to check 10 is lesser than 4 or greater than 4. 10 is lesser than 4 or greater than 4. 10 is greater than 4. If it is greater than 4, we need to update L by mid plus 1. We need to update L by mid plus 1, 1 plus 1, 2. It index to L. Again you check what? You need to check that middle is what, if you have updated L and or L, low or high, anything you need to update now. Mid 2 plus 3 divided by 3, 2 plus 3 divided by 2, 2.5, which is 2. Fine. Now mid is 2. 10 is equal to this index 2 element 9. No. Lesser than this? No. Greater? Yes. So what we need to do is we need to update. If it is greater, we need to go towards right. We need to go towards right means we need to update L. H is there only. L updated by 3. Yes. Mid will be updated now. Mid will be updated. Yes. Mid will be 3 plus 3 divided by 2. 3. Here is the mid. Element is present on mid? No, it is not present on mid. Then we need to check out 10 is lesser than 11 or greater than 11. It is greater than? No. Lesser than 11? Yes. We need to make high minus 1. We need to make high minus 1. High minus 1. High becomes 2. Now check out this. Low and high crossed each other. Low is greater than high. Yes. When low is greater than high, we have crossed low by high. At this time, we can say low is greater than high means it's unsuccessful search. Element is not present here. Element नहीं है यहाँ पे. Element is not present. Element is not present. Now listen. Now listen. Now I will need your maximum attention. अब चाहिए मुझे आपकी सबसे ज्यादा attention, क्योंकि अब हम लिखने वाले हैं एल्गोरिदम, और ये एल्गोरिदम आपको समझ में आना चाहिए कि ऐसा क्यों लिखा. देयर कैन बी मल्टीपल वेरिएशंस. आप स्टेटमेंट्स को यहां वहां, कंडीशंस को इधर उधर कर सकते हैं ऑफ कोर्स, बट यू नीड टू अंडरस्टैंड द बेसिक कंसेप्ट ऑफ दिस एल्गोरिदम. अदरवाइज यू विल not actually understand what exactly the background concept of this binary search. There was a question from binary search, almost accurate algorithm was given, but a slight change, and because of that slight change the algorithm has become erroneous, and there was a question based on that in GATE exam. So how you will have to understand, that is the different matter, but how you will have to understand the each and every concept, that why this statement, why not like that, why this, why not that way. If you understand all those concepts, then only your learning will be good, and then only you will be able to solve the questions in GATE. Chaliye, so if you are fine with this, let's write the algorithm. First of all, for algorithm you have been given low and high. Initially lower bound upper bound will be given of array. Fine, lower bound upper bound of array will be given. Array will be given, item will be given to search. But when we should stop the searching, you only tell me when we should stop the searching. In two cases we will have to stop the searching. Either successful search we can prove और अनसक्सेसफुल सर्च वी कैन प्रूव. या तो हमें एलिमेंट मिल गया और हम स्टॉप कर देंगे हमारी सर्चिंग को, या फिर हम ये प्रूव कर दें कि एलिमेंट प्रेजेंट ही नहीं है, ये सर्च अनसक्सेसफुल हो गया है, ये प्रूव कर दें. इफ वी कैन प्रूव द सर्च इज सक्सेसफुल, वी गॉट द एलिमेंट, और at that case we can prove that element is not present, it's an unsuccessful search. In these cases you will have to stop the algorithm, right? So in these cases only I will be writing my loops. I will be writing my loops for these two cases. Let's first wait. Let's first understand how the algorithm works. So suppose I have called the binary search algorithm. For binary search algorithm I have called for an array A, then I have given you lower bound, original lower bound of the array, upper bound of the array, and I have given you an item to search. This is the input of your binary search algorithm. Fine. First of all, I will take one L. L value is lower bound. Why I have taken lower bound in L? Why I am not changing lower bound, upper bound? Just because I will change and L and H in further execution. So I don't want to change lower bound and upper bound separately. That's why I am keeping it L and लोअर बाउंड अपर बाउंड को मैं चेंज नहीं करना चाहता, अपडेट नहीं करना चाहता. व्हाई? जस्ट बिकॉज आई विल when I will go further, L and H value will update. That's why I don't want to change LB and upper bound. That's why I have kept it in some other variable. High is equal to upper bound, and I am writing another statement, mid. These you can keep in 3 different statements also. I don't have space further. That's why I'm writing like this: L plus H divided by 2, and its floor value, integer value. I have calculated initially mid. Now I will write the condition, while condition. While condition will be what? Till I find the element, I will keep searching, or till I can say unsuccessful search, till that I will continue. So what will be the condition? I will write out. The condition will be while at mid index the element which I am searching is not present. Keep continue. Yes, keep continue, so that we can say element is not present on the mid index as of now. No any successful search, and still lower bound or L value is lesser than or equal to H. If these two conditions are true, keep going. Any of these conditions become false, means either you have found the element or you have crossed low and high, means unsuccessful search, element not present. Element not present, right? So either of these cases will be false, means either successful search or unsuccessful search. Inside the while loop, what we will write? What we will write? We will write the actual searching algorithm. What we will do? What we will do? What we will do? We will write here, if, of course, at mid index item is not present. Item is not present. We are going ahead for the searching. So I am checking out if the element at mid index, or let's say item, if the item which I am searching is lesser than A of mid. पहले ग्रेटर लिखा था, चलो ग्रेटर लिख लेते हैं पहले. If item is greater than mid index, I'll have to update low. I'll have to update, then update low by mid plus 1. Else update high by mid minus 1. And once you have updated either low or high, what you need to do is you need to update mid also. Mid is equal to low plus high divided by 2 and its floor value. Keep going with this loop. Once this particular loop stops, it may stop because successful search, element is present on mid index. It may stop because of unsuccessful search, low becomes greater than high. In any of the cases, if the loop stops, I'll have to check if successful search or not. जब हम बाहर आ जाएंगे loop से, I'll have to check कि successful search or not. Then how I will check? It's very simple. I'm writing further algorithm here. If element at mid index is equal to item, in that case searching is successful. Searching is successful, then what should I return? The element where, or the index where element is present, mid index. Current mid we will have to return. Else, if element is not present on mid index, means the algorithm has stopped. This while loop has stopped because of this condition was false, और उसकी वजह से मुझे रिटर्न करना पड़ेगा lower bound minus 1. Successful, unsuccessful search, and here the algorithm stops. ये है सक्सेसफुल सर्च, and this one unsuccessful. आई गेस, आई होप आप सब लोगों को समझ में आई होगी कि ये एल्गोरिदम मैंने कैसे लिखा. है ना. अभी देखो, लुक एट दिस. suppose if this is the middle, my element which I am searching is lesser than middle, so should I search in this much part only or in this much part? Should I include mid for the next search also or not? Just tell me. अगर मेरे पास एलिमेंट मिड से छोटा है तो मुझे मिड को भी अगली बार के सर्च में इंक्लूड करना चाहिए या नहीं? नहीं. व्हाई? क्योंकि ऑलरेडी वी हैव कंपेयर्ड दिस मिड. तो मिड तो वी हैव ऑलरेडी कंपेयर्ड, राइट? सो इफ आई हैव ऑलरेडी कंपेयर्ड मिड, व्हाई टू इंक्लूड इट अगेन? वापस से क्यों इंक्लूड करना? नहीं करूंगा मैं, नहीं करूंगा. That is why I am saying you need to update high by mid -1, not mid. समझ पा रहे हो? Similarly, I am going back again. If element which I am searching is greater than 15, then I should go towards only right half. Yes, I will not include this 15. No, I will not include. ये तो already compare कर चुका हूँ. I have already compared mid index, so why to include it again in my next iteration? Of course I will not. That is why we update L by mid +1, but not only mid. Understanding this? I am not updating L by mid. I am updating L by mid +1 just because mid index to already I have compared now. Right? And that is what the algorithm they have given in that PYQ. There was a previous year GATE question in which they have given an algorithm almost equal to this only, which we have written. Only one changes, actually two changes they made. L is equal to mid and H is equal to mid they have given. Instead of L equals to mid +1 and H is equal to mid -1. In that case, of course, your algorithm will not work properly. Sometimes your algorithm will keep going. It will not stop. L and H will not cross each other. चलती जाएगी आपकी algorithm. And that is where the algorithm was erroneous. So a very small, a very fine detail, if you can't understand, then in that case they will be giving you a small question from that fine detail only, and you will be, sir, I surrendered to that question. Binary search का question था sir, it was very easy but I could not understand how to approach it. Why? Just because when you were learning, your learning was not so deep, so accurate that you could understand each and every element of that algorithm or that particular method. And that is what happens with all the learners nowadays. So if you want to learn, it's not only understanding some method, it's understanding the method till the basic smallest fine granular moment, so that to the fine granular part of that particular method, so that if any variant of that question comes in the exam, you will be able to understand it with more and more easiness. Got it? Now let's see what is the runtime complexity of this algorithm. Runtime complexity of this particular algorithm is big O of log n. First of all, why big O? Just because we can stop the searching when we find the element. It is possible that we will run this particular loop only one times. Only one times loop will run. At mid index only item is present. We will stop the loop. We will stop the algorithm in one time, one comparison, searching done. But if not, then after that we will divide the array, either in the left half we will go or in the right half we will go. Means we are going to go with the n by 2 elements in the next iteration. Then again one comparison, after that another half, then one comparison, another half. when we are dividing the list by half, after each iteration, and if within the iteration we are performing only one constant operation, then the complexity is log n. So big O of log n. चलिए, तो बाइनरी सर्च समझ में आ गया आप लोगों को, तो जल्दी से इस क्विज का आंसर दे दो. दिस इज द क्विज which you need to understand first. After that you need to answer it. You all know that nowadays I bring lots of such kind of questions for you guys, so that at the end whatever you have learned today you can understand how to use it for solving the questions. आज तो नॉन स्टॉप पढ़ाया मैंने आप लोग को, एकदम नॉन स्टॉप. अक्षय कुमार, क्या बात है. एक गाना याद आ रहा है तुमको देख के, जो तुम्हारे सारे दोस्त गाते होंगे, सीधे साधे अक्षय अक्षय. अक्षय कुमार का क्वेश्चन है एल बी -1 क्यों. देखिए अक्षय, हम लो और हाई को अपडेट कर रहे थे वहां पे. आई वॉज अपडेटिंग एल एंड एच, सो एल बी एंड अपर बाउंड were given as input. I was not updating those. I was just updating L and H. Separate variables I have taken. Those I was updating. Fine. चलिए, question is, look at this. What is the question? What is the answer? मैं वेट करूंगा 1 मिनट और आप लोगों के आंसर का. इसका आंसर बताओ भाई. इसका आंसर क्या आएगा? आंसर बताओ भाई, आंसर. लॉग इन. चलिए, कंसीडर अ सॉर्टेड एरे ऑफ साइज n विद डुप्लीकेट एलिमेंट्स. तो चलो हम एक काम करते हैं, n इक्वल्स टू 8 ले लेते हैं और डुप्लीकेट एलिमेंट भी ले लेते हैं. 1 2 2 2 2 2 3 एंड 9. 8 एलिमेंट्स हो गए. यस, 8 एलिमेंट्स. You have been given an element k. Suppose k is equal to 2. What is the time complexity to find that the element k is appeared at least n by 2 in the array or not? तो मुझे ये सर्च करना है. I have to find out that this particular element is present at least half times or not. At least half times or not. How do I do that? So there are multiple methods. First thing is, either you can do, first of all, you can go with here. 2 is present here. No. 2 is present here. Yes. 2 is present here. If 2 is present here, then we will count. 2 is present how many times? 1, 2, 3, 4, 5. Linearly you can check. Right? As many as times 2 will be present, then we will increase its frequency. We will check out the frequency is greater than n by 2 times or equal to n by 2 times or not. If it is greater or equal to n by 2 times, yes. In that case, complexity will be linear. But that particular thing is easy when we don't have sorted array. When we have sorted array, we can take advantage of it. We can take advantage of it. What I will do? I will first apply a modified binary search. Apply modified binary search algorithm. You know what is binary search, no? You know binary search is what? Until you find the element, keep searching. If element is less, you go towards left. Element is greater, you go towards right. So first of all, you start from the middle. Right. Modified algorithm says that if you find the element, still don't stop. If element is equal or lesser, you go towards left. If it is greater than mid, go towards right. So now what I am saying is equal and lesser, for both you are going towards left. So you are going towards left or right, left or right. And why you are going left or right? You are going to find this index. You are going to find this index where 2 is present, where this given element k is present for the very first time in the sorted array in sequence. So if I will talk about these elements are present on index 0, 1, 2, 3, 4, 5, 6 and 7, then I'll have to find index 1. Why index 1? Just because that is the first index in my sequence of array where the element k, which is 2, is present. Right? So what I'm doing is applied modified binary search and find index I. Find index I at which k appears first time in array from starting से किस इंडेक्स पे पहली बार ये एलिमेंट नजर आया. I got it. Now when I got it, array is sorted. Yes, if array is sorted, all the duplicate elements should be consecutive. Yes, if 1 2 is here, every 2 will be consecutive. Yes, I want to find out that this particular element k is present n by 2 times or not. What exactly I will do? I will check out from here after n by 2 index which element is present. After n by 2 index, which element is present? If the same element 2 is present, then from here to here, of course 2 is present. Means the element is repeated n by 2 times. Yes, तो मैं क्या करूंगा, अब इस इंडेक्स पे से n by 2 इंडेक्स दूर जाके चेक कर लूंगा. So once I will apply the modified binary search, after that I will check if on index in the array on index I plus n by 2 what is present. If it is exactly same element k, in that case I can say yes, I will return yes, true, element is present more than n by 2 times. If not, then false. Right? So exactly you need to understand what is the question समझना होगा कि एक एलिमेंट k दे रखा है, कोई भी एक एलिमेंट आप k समझ सकते हो, कोई भी एक एलिमेंट k ले लो, k की वैल्यू 1 ले लो, 2 ले लो, 3 ले लो, 9 ले लो, जो प्रेजेंट है वो भी ले सकते हो, जो प्रेजेंट नहीं है वो भी ले सकते हो. It's just that they have given an element k. I'll have to check if that particular element k is present or not. First I have checked it, where it is present first in the sequence in indexing. I got that I index, yes. After that I am checking that if at I plus n by 2 index also having the same element, means that element repeated from here to here n by 2 times. If not, then I will say element is not present n by 2 times. If suppose I don't get the element at all in the array, I will say no, element is not present n by 2 times. They have given an element k. K is an element. कोई एक element दे रखा है, मैंने k को 2 मान लिया, k को 3 भी मान सकते हो, 9 भी मान सकते हो, 1 भी मान सकते हो, 15 मान सकते हो. Whatever you want you can take. Such kind of question comes in the GATE exam. This is one of the GATE question type of GATE question only. Another quiz for you. Take time, but solve this question. Take time. Why you are considering one element as k? I am considering k which is given in the question. क्वेश्चन में गिवन है वो के, इसलिए लिया। कोई भी एक एलिमेंट ले सकते हो जो आप चाहो, के। आंसर ऑफ प्रीवियस, ओहो मैंने प्रीवियस का आंसर तो दिया ही नहीं, वाह वाह वाह। सो फॉर बाइनरी सर्च हाउ मच टाइम इज रिक्वायर्ड? log of n. For this checking, constant time. So total complexity, log of n. Answer is B, log of n. Array, binary search, a little bit modified also. It is still log of n. Yes, log of n. Then this statement is single constant operation, total complexity, log of n. This one now. Second question. Second question is having a simple small change. Change is what? Now element k is not present. Element k is not present. You will need to find out ki is there any element in the array which is present more than n by 2 times or at least n by 2 times. At least n by 2 times कोई element present है कि नहीं? Now the element is not given. That which element you will need to consider that this is more than n by 2 times present or not. अब आपको element नहीं दिया है, अब element given नहीं है। आपको क्या करना है? आपको ये बताना है कि कोई ऐसा element present है क्या जो n by 2 times से ज्यादा है या नहीं। Any element can be there. What should be the answer for this question? Suppose you have elements like this: 2, 5, 5, 5, 5, 5, 6, 9, 10. 5 is present n by 2 times, yes. But you don't know which element is present n by 2 times. In this case, what you will do? In this case, will you have constant complexity or log n complexity or linear or more than linear? I will tell you one thing. I will give you one particular suggestion here. Again, this is what, if you can solve this particular problem using binary search, this is what the problem solving, this is what the gate exam preparation, this is what the competitive coding, and this is what the placement preparation, everything in single problem I can explain. अगर आप binary search को use करके इस problem को solve कर देते हो तो यूं समझ लीजिए आपको ये सब में कोई problem नहीं आएगी. Look at this, what am I saying? If any element is present n by 2 times or more than that, of course that should be present on middle index. कोई भी एलिमेंट अगर n by 2 बराबर n by 2 times present है तो it should be on middle. Of course it should be on middle. If it starts from here, n by 2 means it goes up to middle, or if it starts from here, it goes up to here. Right means if you find out the middle index element, that middle index element can be your that element which can be present n by 2 times, only that element, और कोई element n by 2 times present नहीं हो सकता. So if you are going to find out middle index element, that is only the element which can be present n by 2 times. तो एक काम करो, k is equal to a of mid लिख लो. K is equal to a of mid. How do you get mid? Low plus high divided by 2 is equal to mid. In that case, you are finding, okay, 5 is the element which is probable that it can present more than n by 2 times. We have not given the answer. I have not given the answer that it is present. I am just finding that which is the element which can be present more than n by 2 times. कौन सा एक ऐसा element है जो n by 2 times present हो सकता है? I got the element 5. Yes, now I'll have to check out that this 5 is present how many times. If it is present more than n by 2 times or not, and for that I will do the same thing which I did in the previous. Apply the modified binary search, find out the first index where the 5 is present, which is I index. Then from here check out I plus n by 2. If there also the element is present, 5 same to same, then you can get it that this is the element, yes, present more than n by 2 times or at least n by 2 times. right? So once k is equal to a mid, then solve same as previous question. And this one will take constant time, this one will take big O of log n time. So total complexity will be log n time. B is the correct answer. And I hope you guys understood what these two problems are. I hope आपको ये दो प्रॉब्लम समझ में आई होगी. Got it or not? See, I always tell you कि आपको क्लासेस में सब कुछ समझ में आएगा. किसी भी क्लास में आप बैठ जाओ, you will understand every single thing in any class you sit. But the later part is the toughest one, which you need to understand, and that is what the most important part for your GATE preparation or competitive coding preparation or your placement preparation. With the knowledge you have, you should be able to solve the question, how to use the knowledge, how to improve that problem solving using your knowledge, and for that you need lots of such kind of question practice, and which we provide on Unacademy Plus. So if you don't want any kind of problems or troubles in your life that sir हम नहीं समझ पा रहे हैं कैसे क्वेश्चन सॉल्व होंगे, हमको नहीं पता चल पा रहा है कि कैसे क्वेश्चन सॉल्व होंगे, कम ऑन Unacademy Plus and we will give you lots of questions for practice. We will give you that dedication or dedicated structured study so that you will be having proper learning that how to solve the questions. Okay, once again I am telling you there is another class of CPU scheduling tomorrow at 9 a.m. Come live so that you can learn how to apply HRRN scheduling algorithm, how to apply priority based scheduling algorithm, and how to apply round robin scheduling algorithm using the knowledge of cricket or video game. I will give some examples from the real life, how to play cricket or how to play video game or something, and from there I will give you the learning that how you will correctly solve round robin questions. And one more thing, another chance you're gonna have, that is the combat. Next particular combat for you guys is on 7th March. This particular combat is going to give you worth 1.8 crore ka scholarship. You will be able to get some discount in your Unacademy Plus subscription and lots of other benefits you're gonna get. So that combat is nothing but this particular combat will be 65-minute ka test. If you will be writing and if you will be in the toppers, you will be getting discounts. It's on 7th of March. If you want to unlock this Unacademy combat, it's absolutely free for all. Use this code VDEEP10 so that you can unlock this particular Unacademy combat. And apart from that, my classes will continue 7:30 p.m. but for tomorrow, all the members, please listen. This is very important announcement. For tomorrow, my classes will be only tomorrow 5 to 6 p.m. Why? Just because there is some changes in some small things tomorrow only. So there are some commitments I am having in the evening later part at this particular time. That's why I don't want to just record and premiere the lecture which I did for 1/3 lecture of this particular series. I don't want to do that. I want to interact with you guys. That's why I am keeping it 5 to 6 p.m. So remember tomorrow's timing 5 to 6 p.m. tomorrow, only tomorrow. Okay, remaining days it will be on the same time 7:30 p.m. only tomorrow it is 5 to 6 p.m. Okay, apart from that, these are the YouTube batches going on. If you want the PDF of the classes or if you want to have the lecture links, Unacademy Gate CS is the Telegram channel you need to join so that you can get the announcement from our team. You can get all the lecture links and all the information and all the PDF of YouTube classes on this particular channel. Apart from that, if you are really serious about your preparation, I will tell you once again, whatever the time you put in your preparation, you should get the earning from it. earning from it. How much earning per unit of time you are getting? That earning can be knowledge earning, that earning can be efficiency you are getting in terms of how much you could read, how much you could finish, how much you can practice, how much you could understand that how to solve the questions using the knowledge. If you are not getting those things on free sources, come on Unacademy Plus or join Unacademy Iconic subscription using this code VDEEP10 so that you can get discount plus my mentorship plus connection of my entire team. Take the subscription as soon as possible so that you will not waste any single day, any single hour, any single minute, and you will have your preparation going on in the more organized, structured manner. The prices written here are the prices after the discount. If you use the code VDEEP10 and get 10% discount, you can see the top educators of country are taking the classes here on Unacademy Plus. One more request with you all is this particular channel is your own channel, so we are providing you lots of free education, quality education. You need to just keep working on this particular channel, and you need to spread the words about this particular channel to your friends, family, anybody who is learning computer science related courses. Please tell your friends that this is the channel where you find lots of great quality content. Keep liking the sessions whenever you come here, keep sharing the sessions, subscribe kar lo channel ko, and keep this notification on. Keep learning happily. I will try to make your learning happy. We will see you soon. Till then, have a nice remaining day. Thank you so much for joining here. Bye bye.